name's Corey Sanders. I'm the Director of Program Management responsible for Infrastructure as a Service. I'm super excited to be delivering a session on Infrastructure as a Service all up, followed by a few other sessions that will go into some deep dive. If there's one thing that you can take away from this session, it's that Azure is awesome. If there's two things that you take away from this session, one, of course, that Azure is awesome, but two is that there's a whole lot of different options for you to be able to get your solution running either in the cloud or connected to the cloud. And I'm hoping to be able to show you all those ways and all those capabilities in my session. Looking forward to seeing you. Something unique and interesting about myself is that I really enjoy dressing up really nicely in the office, and I get mocked for it pretty regularly. But you can see it pays dividends.
And we're back again to the Level Up Azure IaaS for IT Pros Week.
Boom.
And I'm joined on the stage right now by Corey Sanders.
Hello.
In case you've never seen this guy present before, he's rather fast-paced.
Oh, gosh.
So I'll try my best to slow him down a little bit. But,
we'll see what happens.
You get the prestige of coming right after Mark Russinovich.
I do.
And
it's an honor.
You get to fill in the blanks and go deeper on the IaaS side of things. So your video actually kind of already introduced people about what it is that you do. If you want, you can do a quick little summary again or get started or whatever you like.
Yeah.
And we'll just go from there.
Well, and I stayed true to form and I dressed nicely.
Absolutely.
Especially compared to... that's one way to go. So my name is Corey Sanders. I am a Group Program Manager, Director of Program Management, responsible for Infrastructure as a Service in the team. I've been actually in the team for about 5 years, been at Microsoft for about 10, and I actually started Infrastructure as a Service with Mark Russinovich, the last presenter. He and I kind of originally kicked off the project, and been working on it ever since, and did the initial Linux support as well, and so we'll be talking a little bit about that today. So
you're going to be taking the wraps off what are Azure virtual machines, how they work, and that sort of stuff in this little section coming up right now.
That's right. So what I'll probably end up covering, I definitely will end up covering in this session, is I'm going to kind of give an overview course of all aspects of virtual machines, sort of how it interacts, different parts of the system and how it works. And then I'm also going to open up for the next wave of sessions, the next couple hours after me, a lot of demos, sort of a lot of digging in even a step deeper than what I'm going to cover. So I'm going to try and cover Infrastructure as a Service as sort of a nice broad survey course, and we'll take it from there.
Perfect, man.
So shall I proceed?
You can proceed.
Okay, here I go. So Infrastructure as a Service, virtual machines, as we call it. So to kind of start off, the basic question is, what is Infrastructure as a Service? Well, simplistically, it is simply storage, compute, and network. It's very simple, very, very sort of expected what you'd get. But you may say to yourself, well, great, storage, compute, network, I already have that. So what makes it different? What makes it special when it comes to Azure and when it comes to the cloud in general? Well, what my goal here is with Infrastructure as a Service is to make what you do better, make it easier, make it more powerful. And this comes into a few different areas that I'll walk through. One is simply with agility. With the speed and the ability to deploy quickly in Azure, it enables very simple dev test environments. It enables very fast provisioning time. You don't have to worry about long hardware procurement. You can get the VMs up and running extremely fast. With a pre-built marketplace, you can get ISV-based solutions, applications deployed very quickly, including a full SharePoint farm that you'll see later today. You can get integrated operations to be able to manage and control the instances you're running. And, of course, pay-per-use, which allows you to have the most agility when it comes to your revenue spend and what you're going to actually pay for the services and solutions that you build. But on top of the agility, one of the other aspects and sort of the second half of what I'll walk through is sort of how Azure can empower what you're already doing in new and profound ways. One, of course, is with automation, being able to control and manage the solutions that you're running, and we'll see that later in the week, some details on automation. Unified identity, being able to have that single identity across all of your instances that are running both on-prem and the cloud. Operational insights, which I'll talk a little bit about, being able to manage and monitor your instances. DR and backup, being able to have a cloud-based backup and DR solution for your on-prem based offerings. And of course, additional services and solutions that will sort of trickle in throughout the week and be able to walk through examples like Hadoop offering and machine learning. So, okay. So let me actually kind of walk through what does Azure bring to the table when it comes to infrastructure as a service. Well, one is, of course, the operational cost model. And this is where the whole agility story comes from. And to give you a little bit of background of sort of what this even means, one great example is it's holiday shopping right now. And for actually today is Cyber Monday. So this spike that you see here is actually happening as we speak today. And so what we end up seeing is that for a lot of these folks, they end up having to pay and provision their hardware according to that spike, that top period that happens right around the holidays. On the other hand, tax season, especially in the U.S., is a very different time of year, right? That's actually a couple months from now. And so what we are able to do with the agility and the cost model that we offer is we can create the hardware that allows us to put these two together and be able to pay for just the top line in Azure for all services, right? And so this is just kind of the two examples of holiday shopping and tax, but you can imagine as you look at sort of the entire world of services, this is why the operational cost model works, right? It works from a very simple aspect of when we pool all of the resources and all the deployment times of all the land, you can actually put these things together and you start seeing that we pay for the top line so you don't have to. And it allows you to do that pay per use, it allows you to manage it accordingly. And so this is one of the big reasons of sort of how this system works. And you tell me if I'm going too fast, Rick.
No, so far so good.
So far so good. All right.
Well, seen where I can interject if I need to.
Well, please. I mean, jump in if it's if I'm speaking inappropriately. The other thing that Azure really brings to the table that is fairly exciting and really enables some of your workloads to really excel in the cloud is that rate of innovation. We're able to take, just as an example over the last 12 months, the amount of things that we shipped and deployed and offered as part of the overall cloud offering. Some of these are very geared towards infrastructure as a service, but some of them are also auxiliary services and helper services. The ability to sort of come into the Azure cloud and be able to take advantage of these and leverage them in all the different aspects that you want to deploy, whether it be across our mobile services, our websites, or just additional solutions as part of our infrastructure as a service offering. And so this rate of innovation allows you to keep pace without having to necessarily go do a ton of investment on your own. And so that's why actually that rate of innovation is very, very exciting for us. And so the last big aspect of what Azure brings is that global coverage. And this, when it comes to running solutions in multiple regions, being able to protect against regional-based disasters or problems, the ability to have that deployment across those 19 different regions today, with 2 more coming out actually next year. And so those 19 data center regions, the most of any public cloud provider, enables you to deploy and have that DR-based story many places throughout the world. And I'll actually dig into a little bit of that DR story as we go in deeper into the technical bowels, as it were.
Nice.
Yeah. And so the final kind of point that's very critical and I'll spend time on is the trust and control that we offer as part of the Azure cloud. And so I'll dig into a bunch of the details, but whether it be compliance or whether it be technical solutions, virtual networks, forced tunneling, multiple virtual NICs, or whether it be partnerships with Trend Micro, Symantec, etc., the ability to come into the Azure cloud, deploy, and have the security that you need is very exciting and in fact critical for a lot of our customers to be able to deploy. Okay, so let me actually dig in a little bit into how the system works. So running an application in IaaS. So let me walk through these pieces that I mentioned earlier and explain a little bit of the under the covers and what's going on underneath. So storage. Storage is sort of the underpinnings of the infrastructure as a service offering. The key thing of infrastructure as a service is that it is persistent. And so it allows you to save, it allows you to shut down and restart that work later on. And that is really the key aspect of what makes infrastructure as a service so powerful. And so when you look at just a virtual machine layout, the C disk, the C drive, which is the OS disk, is sort of that core boot disk. And that is offered by us and is a persistent disk that you can enable as part of an Azure blob. And so it's backed by Azure Blob, which is available for other uses other than just virtual machines. But we did end up using that same technology to be able to get the benefits and capabilities that Azure Blob brings to the table. And so the OS disk, by default, comes directly from that Azure Blob. We also offer a temporary disk. And so on some of our disk sizes, this temporary disk is spinning media. On some of them, it's SSD-based. And so the key point here, though, is those contents can be lost. So on any hardware failure, we actually don't replicate that content. And the Azure Blob content, of course, is saved across those failures. Now, you can also attach a set of data disks. So we offer, actually, on our largest D series, we now today offer up to 32 data disks that you can attach. And so these data disks are up to 1 terabyte, and they're backed by Azure Blob as well. These are also persisted upon failure. And so one key important point, I put the drive letters in for a Windows disk. They end up being mount points for Linux. And so very similar concept. You can attach the same disks, and of course you need to format them as they come in, and that will enable you to use it. So each one of these disks, they're backed by Azure Blobs in virtual machine storage. And so each one of these blobs, you end up getting 3 copies. And so this is a very interesting aspect. This triplicate copy gives you the highest durability that you can expect from any public cloud provider. It effectively says for every write that happens on your disk, we copy it 3 times before we come back and say we're good. So it gives you a lot of confidence that any single disk failure is not going to cause a problem. As I mentioned before, 1 terabyte per disk, and on the smaller sizes, 16, on the larger sizes, up to 32, with 500 IOPS per disk as well. And so the other beautiful thing about this, with the triplicate copies, it turns your disks orange. Nice. Which is always a valuable thing. But the other actual powerful aspect is with Azure Storage, with these blobs, we actually, by default, will turn on geo-replication. And so an East DC and a West DC, typically, always at least 400 miles apart, we will replicate across these 2 data centers. And so this allows you to defend against those regional disasters using the built-in storage geo-replication. And to sort of show you a picture of what this looks like globally, what I've done here is I've actually colored in all the dots on the map to show you sort of where geo-replication is happening across the different points. So you have a sense of sort of where the data is moving. It's important to note that for as many as possible, we try to keep the data within country. But in some cases, it's not possible given where our current data centers and deployments are. But for example, the 2 Australia data centers geo-replicate between each other and don't geo-replicate with, let's say, one in the US. And so that's to try and maintain some of that local proximity while still giving you that geo-replication promise. And so you can see sort of the locations, the 2 in Japan, for example, the 2 in Europe, and then a larger set that are in the US. And of course, the beautiful colors and patterns.
I would say that, do you have to consult marketing to get those colors?
These are not approved. These are not approved color choices, okay. But they are quite nice. And I ran out of colors, and so then I had to use patterns.
I would say you have some kind of dirt factor going up there for you.
It was not an intentional statement towards any cultures or regions.
Nice.
Okay. After that awkward moment, let me move forward. So the other aspect that's worth calling out when it comes to virtual machine storage is the ability to attach SMB shares. Now, this is super cool, and this is something that I think we're seeing a lot more interest and excitement on as we continue to grow the platform. You can attach additional SMB shares, actually a very, very large amount. Your only limit for this will be end up being actually the NIC on that local machine, and those SMB shares end up being displayed as just, again, additional drive letters that are attached, and they're using Azure files in the back end. And so this really enables a lot of power. And so when you look at sort of this, it leverages SMB 2.1, and it effectively allows a lot of lift and shift based solutions. And so you can point multiple virtual machines to that same Azure file, and you can get sort of that experience of the read-write capability across multiple VMs. It's a really powerful capability if you're using some sort of shared storage, if you're using maybe an application that you want to put in one place but everyone can install from. And so Azure Files, very exciting. It's not just for infrastructure as a service. You can actually use it on all of our platform offerings like cloud services. But infrastructure as a service has really been one that's picked up a lot of interest because of the ability to do that sharing across multiple instances.
We're going to be covering this one and also more depth on each of the blobs, tables, and pages, sort of stuff coming up. up on day 2, actually, on tomorrow.
Yeah.
Just a question on this one here for the Azure Files perspective. Basically, you think of it as a file share that's on the same VNet, the same virtual network that's inside your Azure configuration sort of stuff. So any machine or resources attached to that VNet potentially has access to those individual files.
That's right. Yeah, and it goes directly through storage, so you can end up locking it down through the storage system using the same sort of credentials that you'd lock down a normal storage account with. So yeah, it's really great. It's actually a really fun thing to play with and super easy to use. So yeah, you'll dig into that later this week.
Cool.
So very cool. So the last aspect, and this is a solution that's not yet released, but this was one we recently announced, sort of the last detail for storage, is the premium storage offering. And so this is actually fantastic. It grows out the opportunity to deploy lots of different applications. And so it will offer up to 32 terabytes of storage per VM with more than 50,000 IOPS per VM. And what's really cool is that on the sizes that we're offering this, we'll actually take advantage of that local SSD and be able to get less than 1 millisecond read latency for those cache hits. And so this is kind of an interesting and different offer from what some of the other folks out there are doing. The goal is to be able to create sort of a caching solution that takes advantage of that hardware in ways perhaps your application can't take advantage of it. So if your application isn't familiar with how to use sort of local SSDs as a temporary storage, we'll end up helping you by putting that into our cache solution. And so we are currently working on all of this, and we'll do expect to deliver this actually quite soon. We are still working on names for the cache, so if we've got ideas, please send them our way of what sort of names you think make sense for I shouldn't have opened that up.
Well, I was supposed to say you can use the hashtag level up Azure. Make sure you include @Corey Sanders WA.
That's right. And give us recommendations for what you think that cache should be named, because we're coming up with some. I've got some clever ones, but most of them are not legal approved.
That's what say. Don't mention them here because we still have to make sure they get through.
That's right. That's right. Well, and many of them are offensive, so we'll probably not do those anyway. All right. Moving forward here, and so the last big aspect here to sort of touch upon is virtual machine images, and this is sort of based upon the capabilities of storage. It uses effectively a snapshot-based technology in storage, and it allows you to capture both OS and all disks attached, and is able to sort of replicate that, and you can build multiple copies of it. Today, that actually is a best effort solution. What it ends up doing is it basically takes snapshots of all the disks that are attached to a VM. We are currently working on solutions that will make this actually a consistent snapshot across all those instances that will make it actually no longer best effort consistency, but actual consistency. And this allows you to redeploy as a new VM. You can go back in time if you want to, and it does support both sysprep and non-sysprep. So this is also a very powerful solution built on that storage system. Okay, so that's kind of the storage background. Let me shift over to compute and spend some time there. So with compute, I wanted to walk through some of the different sizes that we've got. Again, the A series, which is one that we've had for some time now. If you can see from our naming of VM sizes, we do need your help when it comes to naming. And so again, back to the disk cache conversation, please help out, or it will be called something like the Z cache or something of this nature.
Sorry, that's the Z cache.
Excuse me, the Z cache.
International audience, the Z cache.
I apologize. Okay. So the sizes that we've got for the virtual machines, we started with A and launched these some time ago. These are sort of the highest value. We offer both basic and standard sizes. They're really good for general purpose, and we do have a high memory offer as well. Now we also have a special offer in the A series, the A8 and A9, and these do have a very high performance CPU and do have an RDMA based offering that allows very high throughput between the instances. This is very common for like an HPC based workload that you may want to deploy. Now, we recently announced the D family, we figured this was so good it had to skip B and C and go straight to D. And so this is a much faster CPU, 60% faster. It also offers a size that goes up to 112 gig of memory, which is really powerful for a lot of solutions, SQL-based workloads, maybe SharePoint, MySQL, etc. If you need additional memory, you can go and deploy that. These also do come with that local SSD storage. So you can use that local SSD storage for any sort of cache that you may have. Now remember, that is not persistent storage. But something like using SQL buffer pools, you can end up setting that up to be able to use that local SSD storage and really take advantage of the full power of that machine.
So non-persistent, just again to reinforce this part.
That's right.
If the machine has to do a restart, or if you restart the machine,
that's right.
It's no guarantee that that data is going to be there anymore.
That's right.
Because the machine could have been reprovisioned on a different piece of hardware.
Exactly right. Exactly right. So the best way to think of this is if you're a SQL user, TempDB is a great example of that, where sort of TempDB, if it goes away, you're not in big trouble, right? It ends up just needing to be rebuilt, right? Whatever caches you may have are sort of good examples as well. You do not want to put any persistent storage there that you are not replicating yourself, right? So we do have solutions where people have built their own replication solution. Let's say, a Cassandra-based solution, DataStax, et cetera, that may have built using that local storage. But you need to make sure you manage your own replication then, because again, you lose one of these instances, hardware failure, what have you, it ends up going away.
So the way you get around that architecturally, you simply have data disks, which you can then go and attach to these machines, and then they are persistent, they're all good.
That's right.
Sweet.
That's right.
Okay.
And the other size, the final size that we've recently announced, but we actually haven't yet shipped, is the G family. Again, so good, we skipped E. And so what this actually enables is a lot bigger VM size. So we go up to 32 CPU cores. It is using the latest generation of Intel processor, which is very exciting. They just released it. And it goes up to 448 gig of RAM with 6.5 terabytes of local SSD. So really a monster of a machine. And it should enable pretty much any workload that you'd want to deploy. Couple this with, let's say, premium storage in the back end, and you've got yourself a nice little system running there. So.
G series,
G-Wiz.
Not available as of yet.
Not available as of yet. That's correct.
But there is a page up on the Azure site that basically talks about what the G series is, and there's even like a little survey there. I think it is saying, hey, if you're going to provision these, would this be of interest to you? Where would you want them to be, kind of thing.
That's right. That's right. And the key thing here is we are trying to understand exactly how much interest there is in these. They are, again, very big machines, and so understanding who really wants them, how much people want them, it is very important for us to be able to make sure that we're keeping up with demand.
So now when these do go GA, anyone will be able to ask for them.
That's right. That's right. Now, to be clear, they will go available in specific regions.
Oh, yeah.
So they won't be in every of the 19 regions, right? We'll pick, based again on some of that survey, we'll pick some of the right regions to go to, and then we'll continue to learn and grow from there. But anyone will be able to deploy them in those given regions.
Okay, very cool.
So, good question, Ryan.
And we also skipped over top of the F machines too. I'm assuming that's like
that's right.
You went from D to,
I went to
G,
E
and F.
E and F, yeah.
So,
that's right. That's right.
No problem.
Well, thank you for reminding me of that. Okay, moving on. Okay, so on the other side of compute, as we look at sort of the deployment of these larger VM sizes, we start looking at how do I deploy these in such a way that I can get high availability? How do I deploy them so that I can avoid those machine failures or avoid those issues where instances go down? And the technology that we offer as part of Azure is called the availability set. And so you can deploy multiple virtual machines into the availability set. You'll actually see a demo of this in the next hour, where you can put, let's say I put in here SQL. It could be MySQL. It could be Cassandra, right? It doesn't actually matter. It could be your front-end website, and you can deploy here. But in this example, I've got the SQL Server primary and the secondary, and the SLA for high availability is built on this. And so it protects against both hardware and software. So to show you a little bit of what I mean, today our hardware is sort of a good example picture of a rack here in the picture, and so we have physical machines that are single points of failure. We also have a power unit and a rack switch that is a single point of failure. So this power unit could go, the entire rack goes down, or the network rack switch can go down and the entire rack will lose connectivity. And in all these cases, we want to make sure that you're protected against that and can recover from these common physical failures. So what we end up doing is we know the layout of the physical machines. We know how they're laid out. We know where the racks are. And so to protect against these single points of failure, we use software to protect it. And so we'll basically have an availability set that will deploy instances across multiple racks. And that is the guarantee that we offer. When you put these instances into an availability set, we will guarantee that they cross multiple racks. And thus, when a rack goes down or a machine goes down, that VM, the other VM, remains up and receiving traffic. And so this allows you to protect against those types of hardware failures that probably plague you on premises. But now in Azure, you don't have to worry about them. And so the final piece of IaaS that I wanted to spend a few minutes on is really focused on the network. And again, you'll see lots of sessions on this throughout the day and actually throughout the week, spending quite a bit of time focusing on network. The first thing to mention is load balancing. Load balancing is a very simple solution as part of the IaaS and Azure deployment. It's very easy and fast to configure this. You can go in a set of virtual machines, let's say VM1, 2, and 3 here, and maybe they're accessing your front end. And so you've got, let's say, a website deployed on these, whether they be IaaS or Nginx or what have you. You can deploy and you can effectively say, I want port 80 to span across these instances. You can do TCP and UDP across them. You can even control down your ACLs. So you can specifically lock down who can access from that load balance port and who can talk to which VM as part of that. And so this allows you to access and just distribute the traffic to multiple instances. You can even control the probe. And so this is the technology that the load balancer uses to be able to talk to your instances to understand if they're healthy. The default is just to ping on TCP. And it says, are you healthy, are you healthy? And if the TCP ACK comes back, the load balancer will continue to send traffic. You can actually program it to make it an HTTP probe. So you can actually ask the load balancer to hit a specific site, let's say healthcheck.aspx, for example. And if that site returns back 200, the load balancer will continue to send traffic. If it returns back anything else or doesn't respond, it will actually stop sending traffic. And this is a mechanism to give you much more control over your load balancer. This load balancer can be configured in a few different ways. One is, of course, the obvious external load balancer, and this comes through a public IP. So as you set this up, you can configure a public IP, and the traffic can either come, let's say, from your corporate side or from the public internet to be able to access this. And that public IP will then load balance across those front ends and control traffic accordingly. You can also configure the load balancer as an internal IP or an internal load balancer, And this will actually configure this such that you can, from your corporate network, keeping completely within your customer network, you can load balance traffic to your front ends and lock it out from public internet access entirely. Additionally, you can do that even for your backend connectivity. So your front ends could talk to your backends, let's say again running MySQL. You can have that be an internal IP address that is load balanced between them, and it enables you to have that high availability both internal and external. And so this load balancing is really powerful across all those different avenues. So couple this high availability solution with the availability sets that I mentioned before, and you now have both a resilient hardware solution and a resilient network solution. And so with the failure of that one rack, the load balancer will detect that it's down. We have the second one deployed onto another rack, and the traffic will be diverted to that first virtual machine that's still healthy based on that probe that's responding, and you now have a high available application deployed, whether that be public external load balancing or internal private load balancing. And all of those are available for you to go configure directly in the portal or through PowerShell or through the cross-plat scripting language as well. And you'll see details on this in more examples later on. Okay, let me touch upon hybrid connectivity, and then maybe we can hit some of the questions.
You were about to say, we do have the ability to take some questions. It's totally up to you based on your timing if you have time to answer some of these. Some of them might be relevant, so I'll let you kind of pick and choose as you like.
We'll finish up hybrid connectivity and then we'll hit some questions.
Sure, man.
How's that sound?
Great.
Okay, so the last aspect here about network connectivity and about controlling the traffic that you've got coming to your instances is the focus on hybrid connectivity. And this, as Mark mentioned earlier, is a really important aspect of our offering and one that we feel is pretty special, actually. So with virtual networks, you can come in and you can define all of your subnets, your private IPs, your DNS. You can configure all this in a very easy to use portal experience, or of course using the PowerShell and CLI-based tooling as well. And this allows you to configure your network as if it were part of your local network. And so when you're connecting to it, you have a lot of different options. One, for a very simple dev test environment, you can actually use SSL-based connectivity. So from a single desktop, a single laptop even, you can connect using just an SSL solution to a gateway that's deployed, and those virtual machines will appear with those internal subnet-based IP addresses, will appear as if they're just connected to that local machine. It's really great for dev test solutions because it constricts it to a single deployment of your laptop or of your desktop, and so it controls the routes from that box and connects only that box to that environment. Now, as you deploy out and maybe your on-premises solution needs further connectivity options, or you actually need to expose this Azure network to all aspects of your on-premises network, we do have the on-premises VPN-based connectivity. We're using a VPN device with many, many options available. You can connect that to our gateway and be able to expose your entire on-premises network to the public cloud, making it very easy to extend your corporate network into the public cloud. And then, of course, the last one, which is a great solution that we offer, it's called ExpressRoute, and this really simplifies your connectivity into Azure. With a large set of very important and very exciting telco providers, you can come in and connect either, let's say, using AT&T, Verizon, BT, and immediately flip on a high throughput, very secure network connectivity from your on-premise solution into the Azure network using the provider that you're already using, right? And so you don't need to go off and necessarily buy a VPN device or spend any time to sort of configure that or deploy it. In some cases, you may just need to call your provider and say, connect me into Azure, and away it goes. And so that is a really exciting aspect and something that should make it very, very easy to deploy into Azure. Okay. So the next section is around connected services and bringing it all together. But before we get there, let's actually maybe spend a few minutes on some of the questions. What do you think, Rick?
Sure, no problem, man. We had a question here from Colin, specifically around the replication of data that's taking place right now. Can provisioning a replication be restricted to one region, for example, to keep data within EU for Europe as an example?
Great question. Yeah, great question. So today, the geo-replication is a defined set, right? And so you can go find this set online on sort of the website to decide which regions are geo-replicating to which regions. For EU, actually, the two regions that do replicate, one is in Dublin and one is in Amsterdam, and they replicate to each other. So you actually, by default, turn on geo-replication, and your EU-based replication will actually be following the rules that you expect as part of the European law. And so because both of those instances are in the EU. So you can't actually explicitly control which regions you want to replicate to, but you can be assured that at least the EU2 replication locations are actually both in the EU.
Very cool. George has one, the differences between the basic tier and the standard tier. And you also didn't call those out with the newer class machines either.
That's
so
right.
why don't you cover both of those?
Yeah, great question. So basic and standard. What you end up seeing with basic and standard, the key thing here is that for basic, it actually ends up being a slight reduction in performance. There actually is a little bit more of an over-provision of those CPUs, right? And so what you'll end up seeing is, if you take a basic size and a standard size of exactly the same, you'll end up actually noticing a CPU-based reduction, right? The actual memory, of course, is completely dedicated memory, and so the actual memory is the same. And so that CPU-based performance, there are also implications around. Let's see. Oh, the ability to actually do, the ability to do auto scale is restricted as well. And so the ability to have sort of that load balance and auto scale solution can only come with a standard-based VM. And so there's both feature restrictions and there's restrictions around the CPU and sort of the speeds and performances that we guarantee based on basic versus standard. The key thing for basic that's really interesting or worth noting, it's really great for dev test for those types of solutions. Perhaps you're not pushing the limit of your CPU or your initial dev test. Maybe you don't need those load balance features. But it also can be valuable for solutions that don't require a load balancer, right? So you can actually sort of take back a little bit of that built-in cost in standard and deploy your basic solutions if you don't need that load balancer available. And so that's kind of the best reasons for basic. and that offering type. So we do expect for some of the sizes, we may not offer basic in the future. It really depends on sort of the nature of the size. For example, A89, we will not offer basic size because that size is all about that CPU performance.
Right.
And so it doesn't really make as much sense to offer sort of a degraded, or degraded is not the right word, but a reduced version of CPU performance for those specific sizes.
And so the same thing applies for the D series and the G series.
We do expect to have a D series basic. We do not right now expect to have a G series basic.
Okay.
Yeah.
Very cool.
Yeah.
Now, you mentioned about the load balancer being able to go off and to do either a TCP check or else to even a custom web page people go off and check.
Yeah.
What about if a VM is down for an individual customer? Jerome was asking that one there. Is the person informed that's actually running the subscription? How are they informed?
Yeah, great
if
question.
at all?
Yeah, great question. So today, the best way to sort of detect that your VM's down is the actual status will pop into the portal experience, right? So as part of whether you took it down or whether we took it down, the portal will show that updated experience. So you'll see, the VM shutting down. You'll see that the VM is rebooting. All of that status that's coming through the system will be exposed as part of that portal experience. Now, sometimes it goes so fast that you may not see it. And so in those cases, if you're not watching the portal when it goes down and comes back up, you may not actually see that it went down and went up. But it's fairly easy to detect those scenarios. You can go into your event logs into the VM and detect that it did happen. And in fact, the event logs will be able to tell you, hey, sort of what happened. Was it a planned or unplanned incident? And so that's kind of the best way to detect after the fact.
And part of what we demonstrated during TechEd Europe just recently, not too long ago, was obviously operational insights.
That's right.
Being able to go off and have a much more detailed view of the machines, the trend over time, and the history, that sort of stuff.
Exactly.
To be able to see what the machines are going off and doing.
Kind of leads me right into this next section, actually.
Well,
so
okay.
maybe we
can transition.
We'll transition.
Like.
How about that? Yeah. So. I'm glad you brought up operational insights. One of the things that we are really passionate around when we look at infrastructure as a service is some of the connected services and being able to piece these things together. So we'll walk through a few as examples, and obviously these are going to get a lot of coverage throughout the week. But just to give kind of a few of the best examples that we've got. Azure Automation, this is a fantastic service. In fact, I use this to monitor and deploy PowerShell scripts that impact my virtual machines or impact other services that I may be running. And so what Azure Automation is, it really is sort of a simplified PowerShell tool that allows you to run these PowerShell scripts without having to have any sort of client that's running them. You don't have to worry about having your machine up and running. You don't have to have another server that's going to manage your PowerShell scripts. It effectively becomes a very small slice of compute that can run this scripting from a full runbook or community-based script, or write your own. The best example I have that I actually use personally and customers use, including a customer called Confused.com in the UK. Should not use the name to indicate anything about why they're using it.
I just like their website.
Their website's great, actually. The robot, I love that robot.
Yeah.
Anyway, sorry. So the way that they frequently use it is they use it to control costs. So you can go in and you can actually write a little script that says, hey, 6 p.m. on Friday, no one's working on our dev boxes. I'm going to shut them all down. And you can go in with a very simple Azure Automation script, and you can actually shut down all of your running virtual machines that may be left for dev test purposes, and shut them down at 6 p.m. Make sure you're not paying for them over the weekend. And then Monday, you can restart them at 8 a.m. And so the great part about this, it really allows you to take advantage of that agility promise of the cloud using a very simple scripting language. Again, a huge community, a lot of different scripts that you can offer, and I think there'll be a session focused on Azure Automation
that's
later
coming
this
up
week.
on actually day 2.
Yep. Operational Insights, as you mentioned, this is a fantastic service. This service allows you to effectively take all the logs from all your instances that are running and be able to do management on them and analysis of them. And so the best cases you use, you can monitor, you can troubleshoot, you can store the logs for later use. Some of the great examples that people use, they detect that half of their machines or a quarter of their machines may not actually be patched to the latest version, which of course is the scary proposition. This enables you to be able to track and monitor and detect that. And so this is actually a great service, not just for IaaS running in Azure. It actually can be any machine running anywhere. You drop this agent on, and so you're running on premises, you're running in the cloud, you're running both. This allows you to create a single pane of glass to be able to track and monitor the health of those logs and that experience. And so really powerful service. Again, it can allow you to do all sorts of things like detecting downtime events and being able to track those events over a period of time. So this is a great service, and I believe there is a session focused on this. There's not a session focused on this.
I think it comes up as a secondary, if you will,
I see.
during one of them. But
Wow.
yeah, it's because it's not in GA yet.
Okay.
So we're hanging in there.
I apologize.
It's all right.
I apologize for that.
You know, we're actually
We'll
talking
talk more about the G series.
We're actually thinking about doing this on a more regular basis.
Oh, well.
So you never know.
I like that. I like where your head's at.
Nice.
Cool. So the last sort of area of connectivity that's worth really spending a few minutes on, we have a lot of interesting solutions around ops and DevOps. As Mark mentioned, DSC and direct PowerShell integration, running the PowerShell scripts directly onto the VMs. So right in the portal, you can go in and launch a DSC script. You can launch a PowerShell script and deploy it onto a VM, whether running or starting for the first time. And so it allows a lot of this management to just, you don't have to log in, you don't have to do remote PowerShell. All that kind of goes away because it runs within the context of the VM. Very cool stuff. Similarly, we have a built-in solution for Octopus, which is a great DevOps tool, and it allows sort of an ALM, sort of a release management-based offering that you can go in and connect to and deploy. This was actually one of our highest voted user voice items, and so we ended up actually supporting this as part of that response. We said, wow, cool, Octopus, found it on user voice, and so we ended up supporting it, and it's very popular, very, very cool service. Similar, Visual Studio Release Manager, and this does enable the ability to go through sort of a dev, test, production environments and be able to manage this. This also is an extension that deploys onto the VM and will manage sort of the state and the deployment experience of that virtual machine. And then finally, for sort of the DevOps closure, both Chef and Puppet have offerings as part of the Azure virtual machine. You can go in and deploy a Chef run list or as part of this, and you can go configure the RB to connect back to that security solution that you may have for your Chef host. You can also do that on the Puppet side for the Puppet Master. And so this enables you to very easily and without having to configure anything special, directly connect out to those instances that you may be running to manage these solutions and run those recipes directly onto your box. The last big connecting service that I'd like to talk about is migration and disaster recovery. One of the things that I hear a lot of folks when they look at the cloud and they start getting going, this ends up being one of the easiest ways to get going because it ends up not requiring you to change a lot of things on premises. You can keep your instances running, but you can take advantage of the cloud scale and the regional support that we have across, again, those 19 regions to be able to hook up migration and disaster recovery into the Azure cloud. And so what's great about the Azure Site Recovery offering, which enables this disaster recovery solution, you can do recovery plans, you can do test failovers, you can try it out, make sure your VMs spin up correctly, make sure they run correctly once they're spun up, and very exciting technology. This coupled with the InMage technology, a recent acquisition, will enable you to run this across any instance you may have on premises. So you can run across Windows, across Hyper-V, across VMware-based instances, even across physical-based instances, and you'll be able to use the cloud for your DR solution.
I got a question that actually came up about the disaster recovery piece from a perspective of connecting it up to System Center on premises. The current requirement is it's Gen 1 VMs.
Yes.
And does not do Gen 2 VMs.
Yes.
So can you talk a bit about why is that?
Yeah, absolutely. Yeah, great question. So the primary reason, actually, when we started Azure, there actually was no Gen 2 yet, right? And so we built our storage system on Gen 1 on that VHD-based format.
Yep.
It is a request that we've gotten specifically around DR, around supporting Gen 2, and we are working with the disaster recovery, the Azure Site Recovery folks to offer that support. The exact timeline we still don't know, but it is something that we'll definitely have to support to enable all solutions to be able to migrate. Yeah.
Another one that kind of came on as well, it's kind of related to disaster recovery as well, is some insights onto the differences between virtual networks up in Azure and the affinity group concept. Can you clarify that?
Absolutely. Yeah, so the current affinity group concept is somewhat of a proximity concept, right? It effectively says, all of these instances need to be deployed near each other to be able to have their network connection working. In some ways, it's actually a legacy concept. It's something that you'll see actually go away over time. The virtual network really is sort of the new concept that will connect your virtual machines together. And so as we sort of deploy new virtual networks, in fact, if you deploy a new virtual network today, an affinity group will not be a part of that deployment. You actually just pick a region, right? And so we've actually sort of broken down some of those proximity limitations that we had to be able to go just region wide. And so over time, you'll start seeing affinity groups fade away a little bit. And as we sort of move more customers to that region wide virtual network, you'll see it sort of disappear into the night. And so it really is kind of an older concept that we're just kind of fading away.
Okay. Cool.
Yeah, good question. Okay, let me charge forward here. So the other big aspect of sort of bringing these pieces together that's very exciting is sort of the dev test focus. And so a lot of connection points with Visual Studio and MSDN. With Visual Studio, you can go in and directly create and debug a virtual machine. You can launch MSDN-specific images. So we have images that are available just for MSDN dev test usage. For example, even Windows 7 client, Windows 8.1 client, and of course the few Dynamics images, GP and NAV, that if you're an MSDN user, you can go in and actually deploy these for dev test, and they are supported for that purpose. So it's very exciting stuff to be able to do that. With some of these solutions, you can actually get magnificent savings. So MSDN deployments in Azure, you can get anywhere from 33 to 99% savings, which is sort of mind-blowing. I think the 99% really comes from the fact that if you're deploying, let's say, a SQL Server solution on top of Windows, the MSDN account is actually paid for those licenses, and so you end up paying a very reduced price.
For dev test.
For dev test purposes.
Right.
Let's
clarify that.
Thank you.
It's not production.
For dev test purposes specifically.
Yes.
Yes, you actually, for deploying within an MSDN account, you must use it for dev test purposes.
Correct.
Thank you. So you have to stop your Bitcoin.
Nice.
Got awkward. Okay, back to the slides. And the last point, Mark mentioned a little bit on this, and you'll hear more about this throughout the week, Docker integration. So as we announced, very exciting, we actually have had support for Docker on Linux in Azure for quite some time. We announced this originally with the original announcement of Docker 1.0. And so with this support, you can deploy directly into a Linux VM. Let's say you deploy an Ubuntu VM, and you want to deploy some sort of Docker solution. We'll actually bring the latest Docker Docker engine onto that machine and make it available for you to deploy your Docker instances. The other aspects that we've recently announced is Docker client support on top of Windows, so you can actually run the client side on top of Windows, and that integration support. We are working on Docker Hub integration on Azure, and so that is listed as the coming soon item, and that will be very exciting to go into the gallery in Azure and be able to pull directly from the Docker Hub and drop it right onto those virtual machines. So very cool stuff. And you'll have some focus on this.
Yes, we have a whole section on Docker integration and also on the Chef and Puppet capabilities as well.
Great. Okay. So let me wrap up with some enterprise-grade focus, because one of the big questions that we oftentimes get, especially from folks who are running sort of large services and solutions, is how do I make sure that this is secure and protected? And again, you'll see a lot of focus throughout the week on this, but to give you kind of just a quick coverage, one, the enterprise focus, a lot of this is about the growing marketplace and being able to say you can deploy from any solution, big or small, right onto your marketplace. And so very exciting stuff. You can see a lot of big names that you're probably familiar with, maybe some small names that you may not be as familiar with yet. And so this is going to continue to grow as we continue to add these partners in. Very exciting. The partners are great. It's been great to enable this and offer this to customers directly. And so we're pretty excited about that. From a Linux perspective, obviously the ability to deploy Ubuntu, as I mentioned, and quite a bit of different Ubuntu servers that we offer. We do also offer Oracle Linux, SUSE for a SLUS-based solution, a CentOS-based solution, and as Mark mentioned, CoreOS, the recent addition. So very exciting, always growing out the distribution list. In fact, if you've got some ideas or some recommendations, please go ahead and send them to me for some other distributions, maybe ones we hadn't thought of, and please let us know sort of what you think is missing. And of course, our community distribution list, which brings in, and I brought in sort of all the Bitnami ones here. I sorted by B, but you can see sort of the bringing in of the community, all the images that are built by the community of all sorts of different solutions. They're full stacks, right? So you can see here the Apache image that has a full stack, or the Alfresco image. And so these types of solutions make it very easy to deploy full solutions very quickly into Azure instances. So the kind of last aspect to spend just a minute or two on is around trust and control. And when we look at trust and control, we really think of it as sort of 4 concentric rings. One, of course, is physical. That is sort of the layout of the hardware, the layout of the data centers, what sort of alarms we have in place, the security staffing, the people with guns protecting these things, right? And so we feel like we have some of the best physical security in the world. But that's not enough, right? That's sort of the starting point. We also have infrastructure-based security, and this means the instances that are running, our actual applications that are running, these follow some of the best and most secure policies that we have. And the years and years of security principles and policies that have been built in Microsoft over the last 10, 15, 20 years, now we just get to take advantage of as we deploy our services and solutions. And so our internal services, they all follow the same principles and policies and secure testing guidelines that we have across the entire company. And so we take this very, very seriously. Now, for your security and for you to protect your system, we have network and then, of course, VM. From the network side, I'll spend a minute or two on, but this ability to sort of secure your virtual network, as I mentioned, the ability to have ACLing control, the ability to force tunneling out of the network into your corporate side, and of course having multiple virtual NICs to be able to control traffic flow on those instances. And then of course the VM side, anti-malware support that's available by default to your virtual machines. Of course partners that offer anti-malware solutions as well. Role-based access, logging, and an encrypted VHD boot solution from a very exciting partner that I'll walk through. So just to kind of touch upon this quickly, compliance, this is a very important aspect of our offering. I highly recommend you go to our website, our security website, and take a look at our compliance offerings. I put in just a few examples here. I'm not going to necessarily go into the details, but we do feel like we have top-notch compliance across a lot of different aspects, whether it be information security standards, controls, or the government and industry standards that you may expect as part of your different regions. So for being able to control access and secure your system, we allow you to reserve IPs. So from your, let's say, VPN device or from your corporate connection, you can program your firewall corporate side to make sure that you lock this down so that you can reuse and reserve those IPs. You can also actually assign a full port range to an IP for secure FTP-based services. And so again, this allows you to lock down your instance in whatever way you may want to. As I mentioned, subnet ACLing. Being able to control traffic between your different tiers. So you have your front end, middle, and back end. You can actually control traffic, right? Put down an ACL, say only this guy can talk on this port, and you can lock down that access. And you'll see quite a bit more of this later in the week. Additionally, you can even control your ACLing back on premises, or go so extreme that maybe you force all traffic to go back on premises. And this is called forced tunneling. A great example of why you may want to do this, if you're using the public cloud as your extension to your on-premises solution, forced tunneling is a great option to be able to make sure all that traffic will go through your proxy back on premises. And so you're using it, you can control that traffic, and you're using it for, let's say, your LOB-based applications. And so this allows you to control that and lock that down. And this is actually, our IT department deploys a lot of their solutions with this turned on. Mm-hmm. And like I mentioned, the multiple virtual NICs. Being able to control the subnet traffic that you want onto each individual NIC, it allows you to have that secure control and perhaps even configure your appliances in such a way that you can control that traffic and be able to monitor which NIC it's going to, and have your management subnet come into a different NIC than perhaps your front-end subnet, and use a virtual machine to actually control where the traffic flows and how that traffic will move through your system. Like I mentioned, a bunch of security partnerships, whether it be anti-malware solutions, whether it be secure encrypted VM solution, the ability to have Barracuda firewalls deployed in the instance, a lot of these options, and we'll continue to grow these partnerships over time. As I mentioned earlier, the anti-malware solution, you can go in and configure either Microsoft anti-malware, or you can use a partner, Symantec, McAfee, and Trend, to be able to configure their anti-malware solutions. You can do this directly in the portal without ever logging on. Just configure it, set it up appropriately, and away you go. And a great example that I have here is the Microsoft anti-malware option, where you can go in and even configure which files, locations are excluded. Do you actually want to run a scan right now? What is your scan time? And you can go completely control this without ever logging onto the box. And as I mentioned, a great partner, CloudLink, offers full VHD boot encryption. And so you can actually take the VHD, the OS boot disk, and the data disks, and encrypt using CloudLink. It uses a BitLocker-based technology, and they manage the keys for you. And so it enables policy to be controlled from their site. Very, very cool solution. I recommend you check it out. We'll ignore that one right now.
Nice.
Yeah, awkward. He's probably asking me about CloudLink. He actually, that was the guy who actually managed the CloudLink relationship. So he's probably like, please stop talking about it. No. Okay, role-based access control as sort of the final point here. As part of the Azure Active Directory solution, okay, we'll just get rid of this here. I don't know why. Okay. Looks like Link is having problems. So sorry about that, everyone. As part of the role-based access control, the ability to connect your Azure on-premise Active Directory solution directly into Azure Active Directory, have your identities move through, and then being able to assign this owner or read-only privileges to be able to lock that down and make sure that perhaps some of your users should only be able to see it through the portal, and others can actually go modify it and update it and make changes to it. And so this is a very exciting solution. We'll continue to expand upon this and add even more capabilities and power to this over time.
So we're not actually going to be covering role-based access in this particular week, but I do know that one of my colleagues, David Tessar, is going to be doing a specific DevOps discussion jumpstarter on this. And obviously our role-based access control is definitely one of those topics we'll be covering in that one.
It should be pretty exciting.
Yeah, very, very cool stuff.
Very good. Yeah, this is powerful stuff. I think this is going to be something that most people end up employing in some form. Okay, and so to kind of wrap up, I have just a few customers that I thought I'd mention briefly, and then we'll maybe close down on some questions and beyond with it.
If you have the time, I'll take it.
You know it.
Okay.
So just quickly, the 4 customers that I put on here, I've already mentioned Confused.com. They actually a leading UK insurance-based solution. They actually do price comparisons on their websites. A very cool solution. Like I mentioned, they use automation to be able to control the cost of some of their instances. They're a great combination of IaaS and cloud services, and a very exciting solution. Similarly, actually, Blinkbox, very similar in sort of the way in which they're deployed, except Blinkbox also uses media services. So they use infrastructure as a service, as well as some cloud services and media services as well, to be able to sort of deploy their website and their streaming site. Actually, a very exciting streaming site that's available in the UK that does sort of latest movie streaming. And really, it's actually a great site. I don't know if you've been to it. They won't let me buy it because I'm in the US, but I keep trying. Every week I keep trying and going and buying, but they won't let me. And so great sort of examples of being able to piece together some of the different parts of the platform, whether it be putting together media services with infrastructure as a service, or being able to put cloud services with automation, with maybe a cache service, and using infrastructure as a service like the Confused.com guys. And so some great examples there of being able to put those pieces and put them all together to make really a powerful solution for you to go use. So with that, let's make sure we actually have some time for the final questions here.
Sure. Actually, one that came up probably around the disaster recovery piece, and it's definitely something we want to call out, is this one here is from Greg. What about backups? Is there still a need to do backups even if you have geo-replication taking place?
Great question, Greg. My answer is always yes, and we'll be doing more around backup here over the next 6 to 12 months as we sort of build more solutions on backup. The main reason for this is that geo-replication is really great in that it immediately geo-replicates everything that happens, including if you make a mistake, right? And so if you're going and updating your SQL database and you accidentally delete some big portion of it, geo-replication immediately geo-replicates that mistake, right? And so now you've got 6 copies of that mistake instead of just 3. So geo-replication is great when it comes to making sure that you've got sort of that steady state, but backups are great for being able to go back in time, being able to correct problems that maybe happen, and being able to sort of recover from those problems. So that's typically why I always say do backups as well. And maybe we'll do this last one from Chris.
Sure.
Yeah. So the last one from Chris here. If you power down a VM, your costs for that VM are not zero, correct? You are still paying for storage, right? Chris, very good question. There's a couple things to mention here. One, yes, that's correct. Your storage costs are still, you are still paying for the storage of those disks while you still have those disks. I will say the costs of storage are fairly low compared to the cost of running VMs, but yes, you are still going to pay for storage, so it's something to keep in mind. The other thing is, when you're powering down your VM, make sure you power it down using either the API or using the portal experience. If you actually shut down the VM from within, we believe that you're going to capture that VM, which means we keep it around to make it sure that capture is very, very fast for you. So we highly recommend that if you're going to shut it down, make sure you do it from the API, from the Azure API, or do it from the portal experience. So even Azure Automation, make sure you use the stop VM functionality. Do not go in and actually shut down the VM from within, because you will end up continuing to pay for that. We keep it allocated to make sure that capture is extremely fast for that process that we talked about to create a VM image. So that's something that's very important, worth to point out. So very good. So let me actually close here on sort of the final points to sort of wrap up what I mentioned.
Sure.
You know, as we look at sort of the exciting aspects of infrastructure as a service, we really want to offer you, as Mark mentioned, that hybrid enterprise grade and hyperscale offering. But really the thinking here for IaaS is, how do we bring our cloud to you? It's not about you forcing yourself to move into Azure or you having to go take this big plunge. We want to help you out piecemeal, right? So maybe you want to start by just using, let's say, Azure Site Recovery. Maybe you want to start with just some dev tests. We want to make sure that those solutions and those options are going to be really easy for you to get going with that agility, that time to market, and that overall lower cost of ownership, and at any scale, really, and at any time. And so I'll be here. I'm there actually starting the VMs. So you just have to call me at any time, and I will start. No, just kidding. We will start them at any time, and that's the exciting part of what the cloud offers.
Nice.
All right. Well, I think that pretty much sums it up here, Rick.
Yep. We've got one of your colleagues, Drew McDaniel, coming up next.
Hit it up.
He's going to be talking about specifically the next level down on the Windows side of things, from the Windows Server applications and how to be able to run them off, as well as some architectural discussion around how to orchestrate and how to set up and architect your solutions and better, and lots of demos.
He's going to do a lot of demos.
As well as lots of questions. So we are, again, cognizant of the fact you guys are all asking questions. We are saving them up for the right persons to be able to go off and answer them. Mm-hmm. Not that you're not.
Oh, no, please.
We did have a recommendation on the hashtag #LevelUpTwitter that we should switch you to decaf, perhaps, for next time.
Is that obvious, huh?
So we'll see where we go from there.
I love my job. I don't know what to tell you.
You got it. Thank you very much for joining us, my friend.
Especially with you next to me.
You make it look easy. You make it look easy.
That's not true, but I appreciate it.
So we have 2 more sessions happening today, and then don't forget that we also have day 2, day 3, and day 4 going into more topics and everything else. Go to aka.ms/levelupazure to see the full list of all the different sessions. We had a couple of questions about slides being available. They will be dependent upon the speaker and negotiating with them if there's anything that can't be shared, anything else like that.
What's it worth?
Well, we'll find out.
Yeah, exactly. Send me a tweet what it's worth. And then, no, just kidding.
And then finally,
these we can make most of these available.
Yeah. And then finally, all these sessions are going to be available on demand within 24 to 48 hours of them being delivered. Stick with us. We're going to be coming back in about 10 minutes or so if you're following us live with Drew McDaniel right after the break.
Drew will be great. Thanks again, Rick.
No problem, man. Cheers.